Welcome to the SEI Podcast Series, a production of the Carnegie Mellon University Software Engineering Institute. The SEI is a federally funded research and development center sponsored by the U.S. Department of Defense. A transcript of today's podcast is posted on the SEI website at sei.cmu.edu/podcasts.
Hello, my name is Suzanne Miller. I'm a principal researcher here in the SEI's Lifecycle Innovation and Automation Directorate. I'm here with my colleague, Will Hayes, principal engineer who works with me in that directorate, and Dr. Carol Woody, who's a principal researcher over in SEI's CERT division. So today we have a lovely cross-collaboration across the Institute to talk about Agile and cybersecurity. So CERT does cybersecurity, our team does Agile. We're going to talk about them together. So before we do that, I'd like both Will and Carol to just tell us a little bit about what is the work that you do here and what's important about that work from your viewpoint.
Please.
Well, I lead the cybersecurity engineering team, and we're really looking at how do we integrate security and survivability into the life cycle early enough so that we can build the system to be operationally protected.
Okay. And Will.
And I work with mostly major embedded weapons systems in the Department of Defense, heavily engaged in Air Force programs, working directly with the program office and helping them to maximize the adoption and the benefit accrued from these new ways of working, the use of DevOps pipelines and ways to accelerate the speed at which we go from an initial concept to no-kidding operational capability. We're trying to dramatically increase the rate of value being delivered.
So increase the rate of value being delivered while preserving attributes that we really care about is what we're talking about today. So that's the Agile and cybersecurity thing. So you've explained a little bit about Agile, but give us a little more about Agile and a little more about cybersecurity so people can get an idea of how they kind of work together.
Well, so anymore, the term Agile really doesn't do an adequate job of talking about the challenges being faced, because the notion of 7 plus or minus 2 people sitting on a Scrum team working on code that gets pushed out on the commodity hardware, that is not what we're talking about. What we're talking about is incremental realization of capabilities at a system level. And so the infrastructure required and the good practices that are essential to being able to achieve those goals are really under-explained when you talk only about Agile. If it's not secure, if it's not high quality, then you're not delivering value. You're not increasing the speed at which needs are being met. You must have the must-haves is one of the ways we talk about it. And so let's talk about must-haves.
Well, one of the must-haves is definitely cybersecurity, but essentially how we've had to think about cybersecurity has changed because the role of software has expanded so exponentially in the last 20 years, if we want to think about it. It's gone from under 50% of functionality to over 90%. So we're dealing with a much more malleable component that is controlling our systems and technology. We're also dealing with something that cannot be perfect. It's always got defects. The best we can do is high quality, and that still contains a good number of defects, and our research has shown that a good number of those are cybersecurity vulnerabilities. So we're dealing with a product that's going to have vulnerabilities. How do we keep them as low as possible so that we can produce the highest quality and have the lowest number of vulnerabilities in the operational environment?
So when Will talks about incremental realization of capability, sort of the Agile and Lean kind of mantra, and we talk about security and product defects, a lot of those defects don't show up right away. So how are we dealing with the incrementalism of Agile versus the I need to see the product to know if there are operational defects in it? That seems to be one of the big challenges in talking about these together.
I think there's another piece of it as well, and that is that frequently you're building a lot of pieces or you're including a lot of pieces that were built for other things. It's the reuse that's also tied together. And what we care about for cybersecurity is the end product of how all of these parts fit together. But what we also care about when you're putting a system together is that if you're going to field or when you're going to field it, that you've got the best security in place at that point in time. So that depends on what you're doing with it, the context it's going into. And that needs to be factored in as part of how you build the system.
Sure.
And right now, most of the development practices don't automatically include that.
Yeah, so I think we're discovering, and we've known this for a long time, that looking at a product after it's quote-unquote finished and evaluating its value is inadequate, that the investment you make in the care you take needs to match the environment in which you're going to push that product. And so it is what you do before the product exists that determines, to a great degree, the level of security, the level of all the quality attributes we care about. True, you will never find a memory leak inspecting a requirements document. So there are realities of the situation, but the concept of going fast really is predicated on doing it well from the first.
But doing it well in the Agile kind of construct doesn't mean doing perfect requirements completely and then doing perfect design completely and perfect implementation completely, right? It means architecting things in a way so that we can do an incremental piece where we get all of the quality attributes associated with that piece embedded into it.
But let me add a factor around the decision-making and the risk concerns need to be factored into that.
Yes.
As you're building the code, you've got to be looking at it to make sure that you're not coding in vulnerabilities at the individual component level. As you're putting the pieces together and understanding the personas that are going to be using it, the attacker is one of the personas that needs to be thought about in terms of what you're dealing with. And as you're looking at what you're concerned about, you have to prioritize the threats and the potential impacts that could occur based on the context of where you're fielding this and how you're operating it. That is not traditionally part of, even in the Agile development, how they've been building their requirements.
Right. The discussion at the beginning before we implement.
Well, also getting the right expertise, because understanding risk requires the knowledge of how things could occur.
Sure.
And your average stakeholder is not fully aware of how their system can be attacked. So if you don't have experts there that can bring up those issues early, they're going to be missed until the experts do come in. And we have typically not brought the security knowledge in until the tail end. And it's too late.
So what it means to do a good job includes the engineering trade space has to encompass these considerations. We no longer can tolerate, I've done a good job, it works on my machine, throw it over the transom into a completely different environment and say, well, that's your problem because your environment isn't, there's no parity with mine. That's not a responsible way to build the systems of today.
Plus, we also have better tools for finding the security problems, and those have to be incorporated as part of what we do in the pipeline. So that when you build software, you run it through the scrubs and identify the vulnerabilities and fix them then, instead of waiting to the end till somebody runs them, does a penetration test, and finds all kinds of gaps.
So what are the challenges? I mean, we're talking about a concept that we've talked about in another podcast called shift left, right? You know, shift from the right-hand side of the life cycle, shift security involvement to the left, to the earlier phases and also the earlier increments.
That's too simplistic. What you're really needing to do is look at, I'm going to build these increments, so what's the security I need for each one of the increments?
But that means I've got to start at the beginning.
You do have to start at the beginning, but you also don't want to overbuild.
True.
To the ultimate of what you need right at the beginning.
Right.
And too frequently we see security people bring in a stack of controls and say, I'll approve you when you put all of these in place. That doesn't directly link what we need to do for security with what we're trying to do at each point in time. And so the structuring of how we interface all of these pieces and how we really think about it really needs to change.
And I think one of our colleagues, Nanette Brown, has put out a blog post on what do we really mean when we talk about shift left, because I think the shorthand that serves us well in getting people's attention may gloss over some of these notions. It's not simply moving something that used to be done in one place to do it in a different place.
True.
It is a different implementation, and it is when you try to assure and you try to do these other areas of focus in a different time and a different level of maturity for the product, they play out in a different way than they used to. The amount of information available to you is different. The infrastructure that you need to build for yourself is quite different. And modeling and simulation and personas and really challenging yourself is an essential part of what it means to truly shift left.
And the knowledge that you need doing each one of those pieces is different, because we're looking at having to have the right skills there that can execute the new tools, that can understand the outputs and know what's important and make those prioritization trade-offs.
Is the use of a particular type of scanning tool, for example, the right kind of tool for cyber physical versus a payroll system? You know,
And
one of them,
code you're
it might
doing.
work. It might work well in one setting, but not another. And just because I can check the box that I did this particular code scan doesn't mean that I met the risk needs of this particular setting, or I might have overmet the risk needs and overdone it. So all of those things play in.
So there's an opportunity that comes from this as well. And our friends at NASA IVNV in the Orion program, one of the things that their comprehension of what it means to do incremental release led them to really understand in a different way what it means to add assurance to a program like the one there. It's a very aggressive, very ambitious program, and it caused them to reconceptualize what it is that they're working on. They're working on a mission, not a vehicle. And so when we look at the vehicle from the lens of a mission, the areas of focus, the expertise that you need to bring to bear really fundamentally shifts. And it's more than a shift left kind of shift.
Yeah, it's reparsing what's important is what it boils down to.
So how does Agile, from your viewpoint, help with that? How do the principles that come along with Agile help you make that shift? Or another way of saying is, what are the challenges of that kind of different way of doing business that you may be able to get some relief, you know, from thinking about things from an Agile perspective?
I think it's really part of the Agile perspective to put information together and to pull people together to be constantly discussing things and working on them as you're moving towards some vision.
Right.
And typically security has not been part of that, developing the vision. What does secure look like for this product? Not, oh, you've given me a product and I'm going to test the heck out of it and prove I can break it. It's a very different way of thinking about it. It's going to require different participation potentially than the people that are currently doing that tail end break check, so to speak, because they've got to be part of the thinking process, part of the view of how could something be attacked. Is it a big enough risk now, or is that something we need to stage later in terms of prioritizing the issues? And so it's not that one group is more important than the other. It's
Everybody needs to work together.
Everybody's working together. And I think Agile does foster that much more effectively. And also what we've seen with some of the tracking of defects is done more effectively in the Agile environment. And then that can be leveraged to determine potential vulnerabilities that need to be identified.
And what are some of the risk profiles that are apparent early on? That's one of the things I see is the incremental development. You get a view into not just the number of defects, but the character of defects. And some of those have security implications, some of them don't.
Right.
But you start to get an early view as to where I may need to spend more effort, time, subject matter expertise to get some of these defects, prevent them from occurring in later increments.
So if I can pull that thread a little bit, I think one of the fundamental things that we try to encourage our customers to understand is that you are seeking learning opportunities. A larger number, a more frequent experience of learning what it is we're building and how this is working. Having multiple opportunities to look for issues is a benefit. But the fact that we are purposely choosing to make smaller batches of work forces us into understanding the engineering trade space in a different way.
True.
And the infrastructure we need to build to model or simulate aspects of the system that we are not choosing to build on this increment forces us to a more formal understanding of really what we mean by these system interfaces, what we mean by what it means for this to work well. And to really think about not just is there a happy path through this code that leads to the confirmed behavior I'm looking for. You really need to say, are there paths through this code that are adequately walled off? Because if you're building a stub for a feature that hasn't been built yet, you really need to understand that interface much more clearly than waiting for the integration explosion to work out what the interface really was, because you didn't take the time to think about that. The formalisms that come into play really cause you to do a much better job, I think, when you successfully break things into small batches. The challenge is many people look at that and view it as, well, that you're just prolonging the amount of time required to do this. I think the data show us that at the end of the day, doing the work correctly the first time, as opposed to doing it over and over and over again, leads to faster delivery and ultimately a better product. That is something you need to prove to yourself. That is not something that you should take a salesman's word for, obviously.
And I want to pull on the integration thread, because what we haven't really mentioned, the frequent integration that's typical in Agile settings is one of the things that actually enables us to explore some of that threat space and some of that vulnerability space, because we're not just looking at, I'm building 16 components and then I'm going to do a big bang integration. We're looking at integrating all along the way and doing it frequently.
And the problems can't be verified until you do the integration to make sure that the decisions are made. And I think, too, the eyes are on the right kinds of problems at that point, of does it work well, et cetera. I think one of the risks, though, we see is frequently Agile is being used as a faster way to drive cost and schedule. And here we're really talking about cost, schedule, and an emphasis on quality, because that's really the driver that's going to get your defects down, improve your vulnerabilities, and the integration pieces, as well as the appropriate requirements are the important.
And from an Agile Principles viewpoint, quality is part of what we're looking at embedding into our Agile development cycle. Unfortunately, sometimes it's one of the things that gets left out when we're making those drives to cost and schedule, that it, just like every other process, quality can be the first thing to go. It's not meant to be, but what we're highlighting is if it does go in Agile, one of the things, though, I think is you'll see that faster. You're going to see the defect profile, go up very fast, very, very high if you're not paying attention to quality. And that can be a signal that you've got to slow down and pull back a little bit.
Assuming you've got the right eyes on the problem.
Assuming you have the right eyes on the problem, absolutely, I agree. Yes, we've got to have the right subject matter experts. Are there barriers within the security community itself to being part of the development cycle in the way we're talking about, or is that just really, is that a myth, I guess is what I'm asking, or is there really something that prevents that from occurring?
I don't think it's so much that there are barriers as the mindset has been very heavily focused on compliance. I have this list of controls that somebody said I have to implement, not necessarily identifying what are the threats that those controls are designed to address. And so if that's the way you're looking at the problem space, it's going to be very hard to tie these pieces together. And so you have to think about what it is I'm building differently. And that gets back to your point of it's a different mindset you have to bring to this construction.
A purely retrospective view of what has been built and whether or not is adequate, I don't think that's going to suffice going forward. I think we need to, and really the risk management framework is meant to say what are the controls that need to be in place, how do you know that they are serving you well, so that the continued work that you're going to do will continue to lead to the outcomes you want. Not do we look back and make sure the dies were audited in the the I's were dotted and the T's were crossed as they should have been. That kind of perspective, we can't afford that anymore. The scale of what we need to do and the expansion of the risk space and the number of vulnerabilities we face and how rapidly they change prevent that process from working anymore.
There's another piece too in that the security testing has always been thought about as looking at the system as a whole. And so figuring out how to define that in a way that as you're integrating pieces, you can begin to test it is going to force some changes in terms of how we think about structuring those steps.
And we know that one of the shifts in the community has been from DevOps, development and operations integration, to DevSecOps, integrating security into that, I think, because of exactly what you're saying. If we can't figure out how to automate the security testing as much as we've automated the functional testing, we're going to be at a loss in terms of being able to give confidence to people that all these things along the way actually do work together the way they intend.
Or you end up with an extra step at the end that slows everything down to catch up with the security pieces when they can finally look at a total system. And that defeats the whole purpose. And
it really needs to be viewed as an engineering challenge, not a checking, making sure,
not a compliance
inventorying.
Right.
And the process of building things like software integration labs, frameworks for assuring good practices, those need to be tested with an engineering mindset, not a conformance to the document that describes the steps you should have followed in doing this. Those are inadequate for the dynamic world we're in today.
So this is the beginning of a conversation. I'm really glad to be a part of it. Where do you see this collaboration on Agile and cybersecurity going? What kind of plans do you have at this point for doing work together to bring these concepts into greater focus for people?
Well, I think we have to draw them into actual projects and identify gaps based on how we see things working versus how the realities that we're dealing with. We're hoping to relate it and connect it with maybe some of the work that we were talking about that NASA's doing, but also to mine some lessons learned as we're looking through Agile projects as they're attempting to try these.
And I know there's at least one place that you and I are working together where there is going to be security risk assessment. There's also going to be Agile readiness and fit kind of adoption. I'm looking forward to kind of looking at those together to see where some of those mindset shifts may be apparent. Either they are happening or they're not happening. So I think we've got a lot of different ways to attack this problem, but we are at the beginning of looking at things this way.
And tied to the group that we're looking at, they're planning to do all of these pieces. So how do we support their preparation for that in terms of being ready at the right time? We don't have direct answers for that, so we're feeling our way through.
Which is exciting.
Oh, yes.
So I think we're going to see a maturation of the way we think about what our products do for us. Many large-scale programs have traditionally, due to realities they face, focused on the duration of work and the cost of that work. It's as if for some of these programs we've hired someone to fill potholes in our city, and we've given them a budget to make sure they don't exceed the dollar amount, and we've given them a schedule to make sure they don't work past. But no one goes around to make sure the holes are filled or that the material that's placed in the potholes is adequate to the job. Our focus on what it means to have secure systems, our focus on what it means to do a good job of engineering these things needs to change from that mindset. Now, obviously, the world is not uniformly described in this pessimistic way I've described, because there are many very capable, very powerful systems out there that we've come to rely on every single day. But the scale at which these operate, the critical dependence we have on them is making it so that our mindset needs to shift to understand more clearly what it is we're paying for when we buy these systems.
Any closing comments from either of you on this subject?
We live in interesting times.
We live in very interesting times.
We do.
I want to thank both of you for joining us today. I think this is an exciting new area for us to be exploring at the SEI, and we have some really interesting projects that we will, highlight as things go along to help people understand how they might be able to shift their own mindset in these areas. So thank you so much for opening this up, and stay tuned. We will be continuing. Any of the resources that we talked about today, we didn't really mention very much specifically, but we'll make sure that things are in the transcript. And there are some things on Agile, and there are some things on cybersecurity. So the software assurance framework, measurement, there's a bunch of stuff that we'll add in to help people understand where we're coming from as to why we think this is actually kind of something that we need to be paying attention to. Thanks very much for viewing.
Thanks for joining us. This episode is available where you download podcasts, including SoundCloud, Stitcher, TuneIn Radio, Google Podcasts, and Apple Podcasts. It is also available on the SEI website at sei.cmu.edu/podcasts and the SEI's YouTube channel. This copyrighted work is made available through the Software Engineering Institute, a federally funded research and development center sponsored by the U.S. Department of Defense. For more information about the SEI and this work, please visit www.sei.cmu.edu. As always, if you have any questions, please don't hesitate to email us at info@sei.cmu.edu. Thank you.